Hello everyone. I would like to take a look at two examples using the product to sum identities. So these identities give us a way where we can change from having a multiplication of a couple different trig ratios. We can change it into addition or subtraction, which depending on the circumstance can definitely be easier to work with. So depending on which two we're multiplying together and depending on the order they're in, that determines which one of the identities we're going to use. So my first example, all I want to do in this case is I just want to do a little bit of rewriting. So sine of 4x, and this is times the cosine of x. So I have a product, and I want to rewrite this as a sum or a difference of trig ratios. So I'm going to take a look. I have sine times cosine. So sine times cosine, our identity for this. So sine of alpha, cosine of beta, this is equal to 1/2. And then it is the sine of the two angles added together, and then plus the sine of the two angles subtracted. So that's the identity we're going to use. And again, this just depends on which two I'm multiplying together and which order it's in. Since that alpha and beta, we have 4x and x. So this is equal to 1/2. And then we have the sine of the two angles added together. So this is the sine of 4x plus x, and then plus the sine of the two angles subtracted, 4x minus x. So we can combine like terms for each of these. So this is the sine of 5x plus the sine of 3x. And then to finish this off, just so that it is solely a sum, let's take our 1/2, we'll distribute it to each part. So we have 1/2 the sine of 5x plus 1/2 the sine of 3x. So there we go. We're able to take that expression, use our identity, and now we have it written as a sum instead of a product. Okay, so that's rewriting it. Now let's take that idea and we'll go one step further, and we'll use our identity to help us find an exact value. So we've seen this idea already with our sum or difference identities, as well as the half angle identities. But what we're doing here is we have the sine of a couple angles these are not common angles. So 172.5, 127.5, those are not angles that are on the unit circle. But if I can use my identity, maybe if I add those two angles together or if I subtract them, maybe that will give me angles that are on the unit circle, and then I can actually figure out the value. So this product is sine times sine. So the identity for this one, sine times sine, that is the same as 1/2. And then it is the cosine of the two subtracted, and then minus the cosine of the two added together. Okay, so that's the identity we're going to use for this. Do have to be careful, I have this 2/3 out front. That is going to need to continue down as I go through. So we have 2/3 and then times, so now we have our 1/2 from our identity. And then it is the cosine of the two angles subtracted minus the cosine of the two angles added together. Okay, let's see. I'm going to multiply these two fractions together right away out front. So the 2's will just simplify. So this is the same as 1/3. And then inside our brackets, if I subtract these two angles, 72.5 minus 127.5, that is 45. So that's good, because 45, that is a common angle. That is one that's on the unit circle. And then the cosine here, if I add the two together, 172.5 plus 127.5, that is equal to 300, which is also an angle that is on the unit circle. Right, so now we have angles that we can work with, and we can substitute those. So the cosine of 45, that is the square root of 2 over 2, and then minus, let's see, the cosine of 300 is positive 1/2. We do have a common denominator inside, so we can subtract these fractions. So you have 1/3, and then that's going to be times. We get the square root of 2 minus 1 all over 2. And then to finish up, multiplying these two fractions, so 3 times 2 in the denominator, we get the square root of 2 minus 1 all over 6. And it is common to see maybe just rearranging that. So negative 1 plus the square root of 2 over 6. Not completely necessary, but a lot of times we like to have the radical at the back. But anyway, there we go. 2 examples using the product to sum identities to change from multiplying some trig functions together, changing that into adding or subtracting them, making it a little bit easier to work with.